ಮಕ್ಕಳೇ, ವೆಲ್ಕಮ್ ಯು ಟು ದ ವೇದಾಂತ ಕರ್ನಾಟಕ. ಇವತ್ತಿನ ಟಾಪಿಕ್ಸ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಅಂಡ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಆಟಮ್. ಸೊ ಆ ಎರಡು ಚಾಪ್ಟರ್ದು ಯಾವ ತಪ್ಪ ಕ್ವಶನ್ಸ್ ಬಹಳ ಸಲ ರಿಪೀಟ್ ಆಗಿದೆ ಮತ್ತು ಯಾವ ಕ್ವಶನ್ಸ್ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಅವನನ್ನು ಹೇಳ್ಕೊಡ್ತೇನೆ, ಆಯ್ತಾ? ಸೊ ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಫಾಸ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಇನ್ ಕೇಸ್ ನೀವು ಏನಾದ್ರೂ ಪ್ರೀವಿಯಸ್ 3 ಲೆಸನ್ಸ್ ಅನ್ನು ನೋಡಿಲ್ಲ ಅಂದರೆ ಹೋಗಿ ಅದನ್ನು ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು ವೇದಾಂತ ಕರ್ನಾಟಕದಲ್ಲಿ. ಸೊ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ನಾನು 3 ಚಾಪ್ಟರ್ದು ಆಲ್ರೆಡಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಅನ್ನು ಮಾಡಿದ್ದೇನೆ. ಸೊ ಅದ್ರ ಪ್ರಕಾರ ನೀವು ರೆಫರ್ ಮಾಡ್ಬೋದು ಲೆಸನ್ಸ್ ಅನ್ನು, ಆಯ್ತಾ? ಸೊ ಈಗ ಒಂದ್ಸಲ ನೀವು ಲೆಸನ್ಸ್ ಅನ್ನ ಓದ್ಬಿಟ್ರೆ ಕ್ವಶನ್ಸ್ ಯಾವ ತರ ಬೀಳುತ್ತಂತ ಯು ಕ್ಯಾನ್ ರೆಫರ್ ದೋಸ್ ಥಿಂಗ್ಸ್. ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ನೌ ವಿತೌಟ್ ವೇಸ್ಟಿಂಗ್ ದ ಟೈಮ್. ಫಸ್ಟ್ ಕ್ವಶನ್, thermodynamics in the first question. Internal energy is a state function. Explain. Okay, internal energy is a state function. They have told us to explain. So internal energy is a state function, that is its value depends only upon a state of the substances. It depends only upon what? State of the substances, but does not depend upon how that state is being achieved. Okay, does not depend on how the state has been achieved. That doesn't depend. Clear? So hega state depend agide, adu depend agalla. Clear? Next, the absolute value for the internal energy of the substances cannot be determined. It cannot be determined, and but change in the internal energy can be measured experimentally. Clear? So it can't be measured experimentally. It is completely been done on according to the internal energy itself. Clear? So next comes delta U is equal to U final minus U initial. So delta U is equal to what? U final minus U initial. So final ಏನು ಬರುತ್ತಲ್ಲ ಅದು ಮೈನಸ್ ಮಾಡೋದು initial ಇಂದ, you will get a value of delta U. Clear? Next comes what? Delta U is equal to reaction is equal to delta U products minus delta U reactants. Means what? Delta U reaction ಹೇಗೆ ಫೈಂಡ್ ಮಾಡ್ಕೋಬಹುದು? Products minus reactant ಅನ್ನ ಮಾಡ್ಕೊಂಡ್ರೆ you people can find the delta U reaction. Clear? Next, delta U is equal to U2 minus U1, where U1 is the initial internal energy and U2 will be the final internal energy. So delta U is equal to U2 minus U1, where U1 is going to be the initial internal energy. Clear? Initial internal energy, and U2 will be the final internal energy. Clear? Next, note, internal energy of a system will change. Internal energy of the system is going to change when heat passes in or out of the system. Heat is going to be passes in or out of the system, plus work is done on or by the system. Next, matter enters or leaves the system. Matter is going to enter or it is going to leave the system. Clear? So that is going to be the internal energy and its function. According to that we have explained it. Clear? So ee tara question kelidre ee tara answer anna ಮಾಡ್ಕೋಬಹುದು. Next, state the first law of thermodynamics, write its mathematical form. idnu 2 marks kelbodu. They might ask the question for 2 marks. Okay, they might ask this question for 2 marks. That is, the first law of thermodynamics states that the energy of an isolated system is constant and the energy can neither be created nor be destroyed, but it can be transferred from one form to the another. It can be transferred from one form to the another. Clear? That is, the mathematical form of an first law of thermodynamics is going to be what? Delta U is equal to Q plus W. Delta U is equal to Q plus W. Clear? Next comes, express the change in the internal energy of the system when no heat is being observed by the system from the surrounding. Heat and observe madilla according to the surrounding, but work done is on the system. What type of a wall does the system have? What type of a wall does the system have? That you should remember. Next is what? No work is done on the system, but Q amount of the heat is being taken out from the system and it is given to the surroundings. What type of a wall does the system have? Okay, ಯಾವ ತರ wall ಇದೆ ಆ system ನಲ್ಲಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. So what will be that? W amount of work is done by the system and Q amount of heat is supplied to the system. What type of a system would it be? Okay, that is going to be what? First question they had asked, no heat has been observed by the system anta, right? So delta U is equal to WAD, that is wall is adiabatic. Wall is going to be what? Adiabatic. Clear? Next comes what? Delta U is equal to Q. Delta U is equal to Q. That will be what? Thermally conducting walls. Okay, that will be what? Thermally conducting walls. Done. Next, delta U is equal to Q minus W. Q minus W, that is going to be what? Closed system. Delta U is equal to Q minus W, that will be closed system. Clear? So this is how you can answer the express the change in the internal energy according to the system. So whenever there is a no heat is being observed, whenever there is a no work is done, and whenever W is amount of the work done. Clear? So ee tara questions keltare. Okay, ee tara questions keltare. This is also called as an application based questions. Idana ಸ್ವಲ್ಪ practice ಮಾಡ್ಕೋಬೇಕು ಆಯ್ತಾ. Next, what is a reversible process? That is the process which is carried out infinitively slowly such that it can be reversed at any instant of time by reversing the driving force by the infinitesimal amount of is called as reversible forces. Okay, that is called as what? Reversible process. Reversible process andre enu? Yavaga process agiruddalla that carried out slowly. The process which is carrying out slowly, that can be reversed at any instant of time. At any instant of time, that is called as reversing the driving force. Clear? Reversing the driving force. Next comes, what is irreversible process? What is the meaning of an irreversible process? So that is the rapid process which cannot be reversed at any instant. It cannot be reversed at any instant of the time by reversing the driving force by the small amount is called as irreversible process. Is called as what? Irreversible process. So whatever the rapid force is happening, rapid force is there which cannot be reversed at any instant. Yav instant nalli reverse ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. Okay, that at any instant of time by revising the driving force by the small amount ಅಂತ reverse ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? Reversible force ಅಂತ ಕರೀತಾರೆ. Clear? Next, explain the different types of energy changes in the thermodynamic system. So they have told us to different type. Okay, they have told us to do what? Different type of energy change in the thermodynamic system. In the thermodynamic system, they have told us to do the energy change. They have told us to do what? Energy change. So energy change is the thermodynamic process which is taking place in the form of what? Work and beat. It is taking place in the form of what? Work and the beat. Clear? So that is, the work is going to be what? Energy, exchange of energy between the system and the surrounding. Work, exchange of energy between the system and the surrounding can occur in the form of work which can be mechanical or it can be electrical work also. Which can be mechanical also, which can be electrical also. Clear? Next, heat, that is the exchange of energy as a result of temperature difference is called as an heat. Okay, obviously yaವಾಗ exchange of energy ಆಗುತ್ತೆ, that time the heat will be released, right? So ಅದಕ್ಕೆ ಏನು ಕರೀತಾರೆ? Heat has been released or also exothermic process ಅಂತಾನೂ ಕರ್ಕೋಬಹುದು ಆಯ್ತಾ. So that is going to be what? Therefore Q is directly proportional to delta T. Okay, Q, that is charge, is directly proportional to change in the temperature. Clear? Next, in this case, change in the internal energy, that is delta U, is going to act like a Q where no work is done at the constant volume and Q is going to be always be positive because there is no work only. Okay, work done is not happening at the only. Yadake constant volume nalli work agalla. Okay, constant volume nalli work agalla. Clear? Next, when heat has been transferred from the surroundings to the system, and Q is a negative when heat has been transferred from the system to the surrounding. Clear? Next question, derive and express for the mechanical work done in an isothermal reversible expansion of an ideal gas. So during reversible isothermal expansion of an ideal gas, the gas expands in a large number. Gas expands in a large number of the step through small volumes against the external pressure. It's going to happen. So aವಾಗ ಏನಾಗುತ್ತೆ? Suppose the gas expands through the small volume dV. Okay, ಅಕಸ್ಮಾತಾಗಿ small volume dV ದಿಂದ expose ಆಗುತ್ತೆ. Clear? Against the external pressure PXP. Okay, PXP. Then the small work done by the gas is given by. The small work done by the gas, it will be given by what? For the reversible expansion, that is mu W is equal to, one second, okay, mu W is equal to minus P experience dV, that is P expertise is equal to B integral BP. Okay, so therefore it's going to become what? Negatively small. Adra salagi ಏನಾಗುತ್ತದು? Negatively small ಆಕಂತ ಹೋಗುತ್ತೆ. Clear? So what happens with the work done now? Total work done by the gas from the initial volume V1 to the final volume V2 is got by integrating the above equation. It is going to be gotten by the integration of above equation. That is what integration according to the volume 1 and according to the volume 2. So what we have got at the upper end, we have got mu w is equal to minus p expert is dv kottidare. Idanna just integration anige convert ಮಾಡ್ಕೋಬೇಕು according to the v1 and v2. Okay, according to the v1 and v2 we have just integrated it. Clear? So therefore what's going to be the value? Integration of mu w is equal to w, that is integration of p expert is going to minus r nRT, integration of V1 to V2, that will be dV divided by V. So for that purpose, for an ideal gas, P initial is going to be what? nRT divided by V. nRT divided by V. Clear? So therefore, W is equal to 2.303 nRT log of V2 divided by V1. By applying a Boyle's law, this is a Boyle's law. According to that, what's going to happen? That is W is equal to minus 2.303 nRT log of P1 divided by P2 will be the solution. Clear? Applying the Boyle's law. Adikinta munche V1. According to the volume only we are going to consider, because at constant volume it's not been producing. Clear? At constant volume only producing ಮಾಡ್ತಿಲ್ಲ ಅದು, right? So ಅದು ಸಲುವಾಗಿ. Clear? Done? Yes. Okay. Next chapter comes structure of atom. Okay, structure of atom. I have taken some questions which has been repeated a lot of times, that we will check it out now from the structure of atom. Okay, structure of atom. First question, give any 5 characteristics of the cathode rays. That is, cathode rays start from cathode and it moves towards the anode. So cathode ray it will start from the cathode, and it will move towards the anode. Cathode in the anode ge move agattadu. Clear? Next, they are not visible themselves, but when they are passed through the zinc sulfide, coating the screen, a bright spot is being developed. That is coating due to the fluorescence is being formed. Clear? That is, in the presence of electric and magnetic field, cathode rays shows properties of negatively charged particles. Cathode ray will show what? Properties of negatively charged particles. Negatively charged particles do properties anna torsutte according to the cathode ray. Clear? Next, thus the cathode rays are negatively charged particles called as electrons. That is also because of this only the invention was done. That is, electrons were there and it was being introduced, and they had said according to the cathode ray dispersion only, they gave that negative charges were coming out. So that negative charges kept the name as what? Electrons. Clear? Then in the absence of the electric and magnetic field, this rays will travel in the straight lines. Akasmatagi absence andre irlilla magnetic field matte electric field irlilla andre even tilkobodu straight line anta tilkobodu. Aita? Next, the characteristics of a cathode rays do not depend on the nature of the gas. Okay, the characteristics of the cathode rays. Characteristics of a cathode rays means what? A cathode ray in character idella, that is going to be what? It will not depend on the nature of the gas and nature of the electrode material. Clear? Next question, explain Rutherford's alpha ray scattering experiment. So they have told what is the meaning of Rutherford's alpha ray scattering scattering experiment. See, very simple it is. So in lower classes you have learnt about the Rutherfords already, right? So Rutherford actually he introduced the protons and neutrons, right? Right? Nucleus protons ಮತ್ತೆ neutrons. ಏನಪ್ಪ ಇದರದು ಚಾರ್ಜಸ್ ಹೇಗಿರುತ್ತೆ, ಹೇಗೆ ಗೊತ್ತಾಯ್ತು ಅವನಿಗೆ, ಅದೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇದೆ. ನಿಮ್ಮ ಸ್ಕೂಲ್ನಲ್ಲಿ ಕಲ್ತಿಲ್ಲ ನೀವು, ಬಟ್ now you are going to learn it in detail in the PUC. Clear? That is, Rutherford bombarded a very thin piece of gold foil with the alpha particles as shown in the figure. Okay, so what he did, he started emitting the alpha radioactive substances with the help of gold foil. Why has used the gold foil? Thin sheet is there, very strong it is. It's not necessary that how much ever temperature you would give it, it needs melting point is very high for the gold. Okay, that much you remember enough. So alpha particles gold foil ಹಾಕ್ತಾನಲ್ಲ, there was a small angle scatterings were present, unreflected positions were there, and ZNS was fluorescent screen which was present. Some alpha particles were scattered back. Okay, ಯಾವಾಗೂ alpha particles ಅನ್ನ ಹಾಕ್ತಾನಲ್ಲ, according it is hitting back and coming out. Okay, some particles were hitting back and coming out, some particles were not passing only. Okay, some alpha particles were not passing through the gold foil itself. Why? Because there was some empty space between, and there was a middle there, it was actually been passing, and at the side it was not at all passing. Clear? Means, sorry, at the side it was passing, but at the middle it was hitting back. Okay, it was hitting back. Why it was hitting back? Why? Because there was the protons and neutrons which were present at the middle. Okay, side kala enu irlilla, middle ashte ittu, adike middle dindane hit hakond bartittu, but side dinda enu bandilla. Clear? Next, this is how it was happening actually. Boom of alpha particles which was there, it was hitting like this. Okay, it was hitting like this, and it was hitting back like that. Clear? Some alpha particles were scattered, and these were the electrons which were present. This is a nucleus which was present. So this, because of this nucleus only, this both the rays were hitting back. Okay, because nucleus present itto. So idella eno, the surrounding was what? There was alpha particles which was passing through the straight. Clear? So what was the surrounding to the nucleus? According to the nucleus, surroundings were electrons, and this nucleus was actually being present what? Electrons nal enuttappa? Their nucleus enittu protons ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇದ್ವು. ಓಕೆ, ಪ್ರೋಟಾನ್ಸ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇದ್ವು. ಕ್ಲಿಯರಾ? Next, you should understand about the observation. Same according to whatever I have explained it, according to that only they will give the observation here. Listen to it. Most of the alpha particles passed through the gold foil unreflected. That's what I told you. Clear? A small fraction of alpha particles were actually reflected by a small angles. They were reflected by a very small angles because it was reflecting back. So then a very few alpha particles, that is lesser than 1, that is 20,000, was bounded back. That is where the deflected by nearly 180 degree. It was deflected by how much? Nearly 180 degree. Clear? So conclusion in barutte on the basis of this observation. So there was a Rutherford drew the following conclusion regarding the structure of an atom. Regarding this, he has given according to that only the structure of that atom. Clear? So that is what had the majority of the particles went through a foil unreflected, indicates most of the space in an atom was actually being empty. Okay, most of the spaces which was around the nucleus, it was completely empty. Clear? Because electrons were revolving at the side of the nucleus, not in a between the nucleus. Clear? Then the scattering of the few particles through the smaller angles, that is very few through the larger angles from the center of the atom, which was indicates the protons are present at the center of the atoms. The protons were actually present at the center of an atom. Clear? That is nearly all the masses of the atom is being concentrated in the nucleus. Clear? Next, what is electromagnetic radiation? So it is a form of a radial energy which propagates through the space in the form of a waves which are being associated with the electrical and magnetic field. Okay, according to the electrical and magnetic field, waves are going to move. How our question is moving, no? Like that only, in the form of a waves they are going to move. Clear? The radiations propagated in the space by the disturbance of the electric and magnetic field are going to be called as what? Electromagnetic radiation. It's called as what? Electromagnetic radiation. Clear? So this is, oh shit, okay. So this is all about the structure of the atom which I wanted to tell you. Okay, we have few more questions also which I will be uploading the sheet to you. Okay, idu one question ide. So which is actually a question. Okay, it was actually a problem which is there. Okay, that also you should go through. So these were the few questions which I wanted to discuss, which were very important, and I have added up some few more questions inside it which was actually repeated also. They were repeated actually. So but short agi yav question ಬೀಳ್ತಲ್ಲ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ ನಾನು. ಯಾವ ಕ್ವಶನ್ ಬೀಳಬಹುದು ಅಂತ ಅನಿಸ್ತಿದೆ ಅಲ್ಲ, ಅವನ್ನೆಲ್ಲ ಕ್ವಶನ್ಸ್ ಅನ್ನ ನಿಮ್ಮ PDF ನಲ್ಲಿ ಹಾಕಿದ್ದೇನೆ. That you can find it in the description. Don't worry, I'll upload it by today itself with the video itself. If it is helpful to you, make sure you'll subscribe to the channel, and see you everyone in the next session.